Hi my friends, today we model this part. You can see here how it looks. And this is the drawing. We start with creating this basic flange with dimensions 142, 18. Then we apply these holes, then this other feature, then these holes, then this other feature, and all the rest of them. New empty document. Take a look of this workbench and select CAD, not Blender, because we create mechanical parts. New sketch in this XY plane, a circle with diameter of 142, close, and we apply pad with a thickness of 18. This 6 counterbores have dimensions here 11, 18 and 18, 6 times. The circle is 118 where they are. This face for a new sketch, circle placed on this axis, no important dimension of the circle because we use hole tool. As I said, 11 is the diameter through all, then counterbore 18 and 11. Okay, we select this last feature and we apply polar pattern. The axis is okay, not 2 but 6 instances for that holes. Next is this feature, but in 2 steps because it's simpler. Dimension 30 millimeters is for the first, then 95 is for the other. Don't forget, radius 8 are the fillets. The thickness of this is 41 minus 18. This face for a new sketch. We draw a large circle, then 2 vertical lines. We connect these 2 ends of a line. You see here the mark, then also vertical. They are equal, this with this. We apply the distance of 30 between these 2, and we apply trim and we project this circle and we make equal this arc with this circle, and both are placed okay. Close, pad, 41 minus 18. The other contour for that feature is a circle. Let me see inside. The circle has this center and the diameter is 95. I see here a tangency. It is not okay. Close. Let me see what about this dimension, the sketch of that hole. I forgot to place this dimension. You see here this diameter of 118 is there. Dimension 118 divided by 2. Close. And now we have a good solution. This sketch was made, then we apply pad up to face, up to this face. Okay. Next is this combinations of holes with dimensions metric 14 is this, counterbore of 20 on 4 millimeters. The total depth of this hole, threaded hole, is 32, as you can see. This is symmetrical, and there is another hole, a small one, this one, which has the diameter of 5 and goes through the part from one side to the other. To do this, we have to use datum plane, tangent here, to start that hole. We make visible all the tools, and we select this on this plane with a distance in the Z direction of this plane, dimension of 142 divided by 2. Okay, we hide these work features and we select the new plane for another sketch. The sketch is a circle placed on this vertical. Not important diameter, but important is this distance of 18. Close. Hole, diameter of 18, dimension of 32. Then we apply isometric regular profile of metric 14, threaded with the dimension for the depth of the thread, which is 16 plus 4. Plus 4 millimeters. 4 is for counterbore with diameter of 20 and depth of 4. I want to show you the thread, and I select this model thread. OK. We hide this plane, and now we want to place this feature symmetrical on the other side. To do this, we select the last hole and mirror. What is the plane for this mirror? We have to wait because of the thread. Of course, this is the plane with the name XZ. OK. And we have here the other hole. We make visible again the datum plane, and we select it for a new sketch. The sketch is placed here with a not important diameter but important distance. We can project this line, for instance, to apply coincident between the center and the projection. Close. We hide the datum plane. We have here a hole, a circle, and we use it to create a hole through all the part. The diameter is 5 and the dimension is through all. OK. Now you see this to the other end. Good. We don't want to forget these fillets of radius 8 to each of the 4 corners. We select this edge if we can. Then we press the Control key to select another edge. This one. Again, press the Control key on the keyboard to add all these 4 edges. You see blue, you see blue here, and also here. Yes or not? Not. Control, once again, click here. Then fillet of 8 for all that corners. OK. Another feature is this one. Dimensions are center of diameter of 62, sides with radius 11, this distance of 70. 3 dimensions. What is the thickness? 78 minus 41. This is that feature. We select this face for a new sketch, and I prefer with MMM. You can try with circles 3 circles and tangents. Polyline, starting from somewhere here, going here, then MMM to create an arc, another line, then MMM to create another arc, another line, MMM for another arc, as you can see. Then we go somewhere here, MMM, and we close all this. We have to place on the same horizontal this center with the center of the part, and also this with this. Vertical is this point, not vertical, this is coincident. Coincident this point with this point, this with this, this with this, this here, let me see what happens here, because I cannot place the coincidency. Here is one and here is the second. You have to enlarge the sketch to see better. Now we have a non-tangent here between these two. Now we have equal are this with this, but they also are now equal, and this with this. Now that 3 dimensions. Yes, this is 70. This is a radius 62 divided by 2, and this is radius 11. Symmetry is missing this point with this point and this axis. Now you see a green contour. This is very good. Close, and we apply pad or extrude 78 minus 41. Okay. Next is this internal volume, 46, 37, 32, 15 degrees, diameter of 50, depth of 18, diameter of 62, radius 4. New sketch, this plane, see inside, project this line, then we draw a polyline starting from the center point. Vertical, horizontal, down, vertical, left, down. Now MMM. To somewhere here. Horizontal. Vertical. And back to the center point. We place radius 4 here. An angle of 15. Between these two lines, the angle of 15. Other dimensions, this is 46 divided by 2. This, let me move it inside because the dimension is 30 divided by 2. This is 50 divided by 2, and this is 62 divided by 2. The other dimensions are 37 here, then 18 is this, this is 32, this 32. Now we have a fully constrained sketch. You see, this is the contour, yes, to here and back. Close. We apply this tool, groove. The axis is by default. OK. The part has two holes here, metric 10 with 20 and 15, and other is this hole, diameter of 5. One is here, another is here, distance of 92. The distance between these two is 70. This face for a new sketch. Project this arc and this arc. Draw two circles with random diameter, and we apply hole tool. This is not important, this is important, isometric 10. You see here the two holes. The depth is 20, threaded with the fillet, dimension of 15. Then model thread to see that profile. Okay, you see here the two. The other are placed on this face. New sketch, two circles, centered on vertical, but no matter what is the diameter. Symmetrical, this point about this axis, and a distance of 92. Close. The diameter of hole is 5. Hole, diameter of 5, and the depth is the distance from 41 to 18. 41 minus 18. Okay. Now you can see the holes. This is going inside to here, but not here. Everything is okay. Then I have to tell you, thanks for watching. Bye bye.